There we go. Cool. Okay, we're recording. Thank you everybody for joining us. This is a Containers 101 talk. So as such, there's no knowledge assumed. A lot of the resources that Sai and I have gone through over the past couple of months as we've worked on this part-time is they assume that you understand how to use Docker or understand how containers are different from virtual machines or orchestration or things like that. So we wanted to just start with the super basics and show you what are containers, how do they differ from stuff that you're used to, and what are some cool tricks that they can do. So let's get started. This is a dual production for Mr. Saiji and myself, who we are calling ourselves Team Cyanide because I so frequently say Sai and I because we're always a dynamic duo. Let's kick this off. So first of all, who uses containers? There's a couple of companies that you might recognize that are in the top 10, top 50, top 100 companies in the world that have really taken to containers for a lot of reasons that we'll talk about in a minute. But you'll see Google on there. They launch several billion containers per week. Most of their services are container driven because they're very easy for DevOpsy style automation processes. Also, Netflix, you'll see on there. If you watch television or if you interact with them at all in terms of their like machine learning to figure out what you like, all of that is container driven. All of their Node.js backend is container driven, tons of containers, 3 million a week. And at Uber scale, they are a micro application shop and thousands of microservices serve all of your rides. So they generate about 100 petabytes of raw data a day. So just a huge amount of data. These tools are built to scale horizontally out. So rather than the old school VMs or mainframes where you scale up and have these big old huge servers, these are little machines that you have 10,000 of when you need them and you spin them down when you're done. But those are big companies, right? Like, who actually uses this stuff? It's not just Google. Well, we do. So UDP, not the protocol, the team, as we like to say, uses it for the pipeline and snow loader processes. Practice Fusion uses it for at least the SFN Sparkle Formation Jenkins testing and deploy, and probably a lot more that I'm less aware of. Definitely Kong should be in this list. With Fassel and Sean building that cool stuff, and probably a lot more. Health plan team, the CIAP group, which are on here, at least Mr. Zemp is, build tons of applications that are all micro-segmented. These are all links, by the way. I'll share this afterwards. You might not have access to the source, but you can at least request it and view some Docker files and stuff. And the clinical group, I hope Binky's on here, have built a ton of cool BPMS stuff. They're building test for their application is container driven. And ePrescribe, Ad Agent, and the ERX have a ton of stuff that are in containers. So it's not just super big companies that are, they're othered, they're more advanced or technological or educated or whatever. Like, this is a technology that we can use. It does assume some changes to like application development and some technology that we'll have to learn, but it can do some really cool stuff that Sai and I are going to talk about. First of all, some terminology. In the bottom right, that is a Docker file, which is instructions on how to generate a container, which can be run. So it's kind of like using Packer or Vagrant to like build an image that you can spin up in a virtual machine. Oh, I totally had that already. So this is a container list. It's just an ordered list of instructions. So you can see from Amazon Corretto version 8 on line 4. And then you run commands and you copy files. And it's really not so scary when you see lists like this. Like, this is just any way to build an image that you would run. Each instruction is a layer. So line 4 is a layer, line 7 is a layer, and Docker keeps track of that. This is more of a big company thing or like a rapidly iterating thing where if you change, let's say we changed line 8, line 4 and line 7, the image wouldn't have changed and the run command wouldn't have changed. So the hash doesn't need to be rebuilt. We don't need to do those steps. We can just use that layer. And then line 8 would be different. We need to compute line 8 and everything after it. totally deeper than we'll go, but layers are kept. They use hashing to identify stuff. An image is what you see on line 4. It's a binary snapshot, and you'll see a ton of these published on Docker Hub, which is the Docker company that maintains this open source library of stuff that you can grab. So Amazon publishes Corretto if you need their open source Java. There's also Ubuntu and CentOS and just about everything you can imagine available as an image that you can grab and utilize and sort of customize for your own use case. Containers are generated by the build process. So you use images as part of a layer in a Docker file, and you say build. And it builds a container, and then you run the container later on, and it does stuff. It does whatever its job is. And a registry is a place where you store images. And that sounds like not very important. Like, why wouldn't you just use a file store or a Dropbox or something? Registries are integral to the container build and deployment processes because build and run are totally separate things, and they're sort of bridged together by the registry. And we'll talk a lot more about that. I know that sounds a little cryptic, but we'll dig in. Container strengths. We're steering into Mario. We have all the gifts. Replacing containers is really easy because to have generated that container, you have a Docker file, you have a build process that built that container. And if you need to build something to replace it, you replace the image in the container registry. So you build a new one, put it in the place of the old one. And generally your build processes are pointed at latest or something, and they'll pick it up automatically. And even if they're not, you can just update and say, grab the new version and run it. And the next time they execute, they'll grab the new container. Containers are legion. There are so many containers that are already out there and published, and you can just go and grab and utilize them. And they scale out very well. A lot of the Docker or Kubernetes infrastructure is designed for you to run a lot of them that are exact copies that just sort of scale out. So if you have to run 100,000 jobs, you can just spin up 100,000 containers in a really rapid time span. So rather than spinning up a virtual machine that has to boot the kernel and take ownership of the hardware and then let you log in and then start some services, containers start in a couple of seconds. They're really rapid to spin up. So really common design patterns are you spin up containers when you need them and you spin them down when you don't need them. And you can scale out very rapidly to handle bursty traffic. Oh, I totally covered that one. Docker spin up very quickly, containers spin up quickly. It runs on my computer, which is something, it's a platitude. It's a little whistle that you'll hear on a lot of articles, but it isn't exactly clear what that means and how powerful that is. So imagine a build process or different environments processes. You have a lower environment that's like int or QA, and you slowly promote code to stage and prod. But code isn't a block. It's not a one thing. It has a lot of dependencies. You have versions of Java that you require, versions of PowerShell, versions of the kernel, versions of drivers. All of those are generally promoted through the environments in the same way. And now imagine you have the job of coordinating, promoting all of those things together. That becomes a very complicated problem, especially at scale. So the ability that containers have of packaging the dependencies that your code requires into a little box that can just be deployed the exact same way on your computer as 100,000 times in an enterprise production environment is pretty cool. To switch over to Docker, that it'll always run the same way on your computer as a developer as it'll run in an enterprise infrastructure. Container build and deploy processes, they mesh well with DevOps. So DevOps means a lot of things. And I know it's just sort of widely understood differently by every different group. But containers mesh well with asynchronous development processes, like I just described. You're developing on your own computer and then you push up a container. But also containers are tagged in the same way that code in a Git repo can be tagged. And you could certainly have deployment to a container registry that has the tag that's used for dev, and it's deployed in dev, and you run all your testing, and then you can promote it. But it works very much like code. It sort of enables you to package all of your dependencies like it's code and promote it across your environments, doing all the tests perfectly because you promoted it through those environments and tested it.
Kyler, can I ask some dumb questions?
None.
You cut out, but I'm assuming you said yes.
Yes.
Great. Yeah, and I probably know the least about containers of everyone on this call, so this will probably be really trivial questions to everybody else, but I'm just curious. So if you want to run like containers on your own computer, like so and then to later promote it through environments, you're installing like a Docker app on your computer, or how does that work?
Yeah, absolutely. So we have a little bit more in depth in a couple of slides, but Docker is a program that it's kind of an interface layer, but it allows these containers, these little boxes of code and dependencies, to share the kernel of a computer. So that program exists, it's kind of like a hypervisor is for virtual machines. You can install it on your computer and then interface with there's a GUI even to click some buttons, or you can run commands. And then it also exists for like Linux-driven kernels where it's more powerful and flexible and used more in the enterprise space. But totally, you can run Docker locally with a Docker tool.
And there's a differentiation between like a Docker Windows container versus like a Docker Linux container. Like it's not a universal thing, yeah.
I would love for it to be universal, but it isn't because of this small little exception on it that it shares the kernel. So if you're running a Windows container on a Linux kernel, I understand that doesn't work. Although there's some experts on the call, I should mention that too. I usually present on stuff where I consider myself kind of an expert, like I know what I'm talking about. This is not the case for containers. Mr. Sai is on the call to back me up, and I know there's a half a dozen folks on this call that have a ton more experience than I do. So if anyone wants to disagree or chime in, please do, or else I'll mislead a whole room full of people.
And then in terms,
I got a really quick anecdote on that. So if you're running Windows subsystem for Linux, like if you're on a Windows machine when you want to run Linux containers, you can do that with Docker Desktop for Windows. You could also do that by running Docker within the Windows subsystem for Linux.
Oh, okay, interesting. So, and then in terms of like you're saying, like, well, containers are often shared. Like they're just sharing like a config file, or basically, right? I mean, that's all that's being shared. There's nothing more than that, or is there more? Is there like, are RPMs being shared as well? Like, how does that work?
It would depend on what your team wants to do, but that Docker build process is pretty rapid. And so you can just share the like ASCII file that's the instructions that says step 1, do this, step 1, 2, do that, and run it on your computer to build the container. Or you could use the Docker tool to log into a container registry and download the container and run it. So both ways work perfectly.
Like a post-compiled container, basically. Okay.
Yep. So if you want to work on the container and change the like version of a dependency, you can download that and modify it and test your code. Or you can focus in on just code development and use the existing container that's utilized in your environment and fiddle with the code and run it within the environment where it will eventually run in production.
Yeah. Okay. All right. Thanks.
Cool. And please bring it on. These are totally great questions.
I'll keep throwing softball questions at you as we go.
Cool. And bring on the hard ones too. Like I said, Sai is here if it goes over my head, which it probably will. I imagine I won't know all the answers to all this stuff.
A question, do you have any information around the difference between Docker and Kubernetes?
We talk a little bit later about what Kubernetes is and Docker versus like LXC. So I'll talk about it there, but when we get there, chime in if there's something that we don't cover.
Okay, thank you.
It's interest. This is a 101, so we're mostly like defining terms, but we will try to talk about that if you have any more questions.
Thank you.
Sweet. Okay, let's do this. Container weaknesses. Oh no, look, he fell off. Sai said this is his favorite video game, so we are steering into this with GIFs as much as we can. Containers are ephemeral. This is both a power, a superpower of containers, and a weakness. So a virtual machine or like your desktop, if you make a change to it, that change is preserved. That change is intrepid. Even if you restart your computer or hibernate it and bring it back. On a container, that's generally not the case. So if you spin up a container and you create some config files and deploy something, and then you shut the container down, those changes are lost. That's an intentional design decision with containers. Point being that they should be relatively immutable. When you deploy them, you deploy the container, you sort of boot the container up, and it does its job, and it shuts down. They're not intended for storing data because you're not writing that container back anywhere. You're not writing it to like non-volatile memory or anything like that. It just exists in memory and it runs its process and then it shuts down, and that's it. It requires kind of a shift in mindset. So what we're used to, I think I have a cute little puppy on here in a minute. There's this very common analogy that you'll hear a lot if you start reading about containers, which is the difference between cattle and pets. Mostly, we are used to development processes where our servers are our pets. We have lots of computers. They are long lasting. They last for months or years. And we take care of them, right? Like we patch them. If they need to be rebooted because the underlying hardware at AWS has a problem, we schedule the outage and we reboot the thing. And they're these big, bulky machines that we come to know, you know? I don't know if anyone else wants to take care of them like their pets, but they're long lasting and you have to care for them. Containers are intended to be like cattle in the sense that there's a lot of them. And if any of them have a problem, you probably just replace that cow. I told my wife I was going to talk about like you take a cow out in the field and shoot it. And she said that is not an appropriate business analogy. So I'm just going to say you sell it. You don't do anything else.
Is this cattle thing like a common like terminology for this, or are you inventing this as we go?
With my farming background, I could, but no, this is a common terminology.
Okay. Common. All right, just curious.
Totally. So you have to sort of get used to that sense where these containers could be shut down and replaced at any moment. So a lot of the infrastructure around containers in terms of like the Kubernetes and the load balancers that drive them are doing health checks against them, and the data is stored elsewhere. The data is not stored on that computer. It's more of like an ETL. It's a bring in the data, transform the data somehow, send it somewhere else that is non-volatile, like a database or a backend of some kind. Container monitoring is a little bit different in the sense that they're all sharing the kernel and running their own processes. So if you wanted to like get into the container, which is what we would do if we had a regular server that had an issue, right? We would SSH in, we would RDP in, we would run our like LSOP commands to look at our processes or top or something like that, or look at the process monitor. Generally, containers you would not get into themselves. You can, we enable SSH or RDP when we need it, but in an enterprise production environment, you will send your logs somewhere else. We'll send the logs to Splunk. We'll send the logs to an S3 bucket or something like that. And you go and review the logs there and you review the processes and sort of aggregate them. They're more enterprise focused because usually there's a lot of them. So if you see a problem, it's not like you might even know which container had a problem, like which individual one. It's more that you would ID a problem with the service and you would need to go to the aggregation point to review the logs. Because if you have 1,000 containers or even 20 containers, you don't probably want to go to each one. That sounds like it would waste a lot of time reviewing 20 sets of logs.
So what are we doing, or what's the best practice around like malware scanning or like perfmon gathering and things like that?
What a great question you've provided.
Is that a Sai question?
I probably is. I know a little.
Yeah.
Yes, all
It's
you.
coming to the next few slides.
Okay, cool.
Oh, it's coming up. Okay.
Yeah.
We do. We have a whole slide on monitoring and security stuff in particular, and it has a great Mario GIF.
Oh, well, I'll wait for Mario.
Containers share the host OS in the same way that virtual machines sort of have this underlying hypervisor where security is focused around like can you get into the container and compromise it, and in that way also escape the container and get to the host? So it is a little bit of a weakness in what I said earlier, which I still think is true, that if you're running a Windows machine, a Windows container, it requires you to provide a Windows kernel. If anyone corrects me on that please do. But that's my understanding of it. So when you have underlying hardware like nodes that are providing they're an EC2 host or they're Fargate or they're something like that that runs containers, the underlying kernel has to match the container type that you assign it to. So generally there's this, there's certainly a deviation between like what kind of containers do you want to run versus what your underlying hardware you've provided and provisioned is. And usually companies centralize around one type, namely Linux and particularly larger shops. Containers use a little bit of wonky networking for the same reason that if you spin up 1,000 of them, how do you address something to it? You just, in our enterprise, when you have these big, like several large machines, and you want to load share traffic among them, you put them in a load balancer in front of them and you address traffic to it. So as part of a lot of the orchestration tools or the managed Kubernetes services, they provide load balancers as part of an overlay network, which is their own sort of virtual network. It's kind of like a VPN network that's shared amongst all of the container hosts. So it's not actually that complicated. There's the same concepts of load balancers and internal IPs. And when you egress that overlay network, the container only network, you get sort of natted to the other network. But it's just a new concept that you have to learn, that it's sort of their own network. And when they egress it, they nat through. So it's kind of like two networks talking to each other. So definitely some networking fundamentals that are required for understanding how containers talk to each other and how they talk to things that are off their own network. And I know CIAP has done a lot of this. I helped a little bit, but I think they figured out most of the stuff themselves in terms of how does DNS work? If you address traffic between one host to the other, which DNS works for the certificate? So questions like that are sort of muddied a little bit by the wonky networking. I think I have a cute picture here. Yeah, this is its own network, which is called the service that maps containers together. And it can be a little complicated. And if I sound like I don't know what I'm talking about, that's because I don't really. This is something I'm learning.
So the containers themselves don't have their own IP address? Or is the host like natting it basically, or?
It depends on the deployment.
That right?
Yes. I know Sai has talked about some of the AKS, the Azure Kubernetes ones, where you can directly assign a container a real IP that's on your network and you can address it. But my understanding is the default is they do have an IP, but it's on their own network. And the only way you get to that other network is you go through the load balancer, which would own an IP on your network.
Okay.
This kind of goes deep, so I don't want to talk about it too much because I don't understand it very well. I'm imagining like maybe in the future, in a couple of months, we have a 201 containers talk or something where I actually know what I'm talking about on this slide and I can present it better.
Sure.
Cool. All right, I will move on. One more slide and then Sai's going to take over for a little while. So there are different types of containers. You'll hear me say Docker a lot here because Docker is far and away the most common one that you will use in your own business, your own building, your own development. Docker has just taken over. So I would just advise learn Docker. But there are other things that can do this. Red Hat has one of the most common alternative enterprise solutions. They both have the like underlying Docker-like runtime for containers, and they can both run Docker because it's so common, as well as their own container spec, which is OpenShift container spec, I believe. You'll also see LXC on the bottom there, which is very widely used by some companies you might have heard of, like AWS, to run all of their EC2 machines. Their internal hardware that's longer lasting is run on LXC. LXC is actually where a lot of these services came from. I don't want to go too deep, also because I don't know a lot, but I read the history of how this came about. And the idea was on the Linux side, where you have a process that spins up and you want to limit what it can get to. So Linux engineers built something called a jail for processes that you spin it up and you're saying, you're allowed to talk to this service and that service and use this many resources. And that idea eventually grew into, let's make a virtual box for a process. And that's basically where containers came from.
Does Amazon have like a branded name for their LXC?
That's a good question. Not that I'm aware of.
So it's like if you spin it up, it's just called like an AWS container, or what is it called?
Well, their current terminology for their current VMs is like their Nitro system, AWS Nitro. So like their newest VMs are on that, and I'm assuming that has this underlying technology.
And is it like is it equivalent, like the config file, like does a Docker config file work the same as an LXC config? You know what I mean? Like, are they interchangeable or are they different format?
My understanding is totally different format.
Okay, so like spinning up an Amazon like Nitro container would be a totally different process than spinning up a Docker container.
Yes, and the Nitro, yeah. We're getting over my head in terms of what I understand, and probably also, but yeah, totally different format to build them. Some of them are cross-compatible in that you build the container and it can be run by others, but it's usually an intentional design decision to support the other Docker container style.
Yeah, and I mean, that's typical with Amazon, right? Is like they'll take an open source thing and they'll fork it and turn it into their own product.
They'll make the whole open source community angry for a little while, and then they'll fork it and steal the ideas. Yeah. Tumultuous history there. All right. I think this is Mr. Sai.
Thank you, Kyler. So a little change from the topic of containers. So we'll also talk about something called serverless, which is a huge competition with container services. So serverless is more of a buzzword and an architecture industry buzzword. Basically, there are servers that actually run every process. It's just that we as consumers don't get access to the server. We only get access to the process. These are more like your AWS Lambda functions or Azure functions and so on. The advantages of that are primarily that we don't have to manage the environment itself, the underlying fabric of the environment. All we need to do is ensure that our code is updated, our code is secure, and everything else is taken care at the back end by the platform provider like AWS or Azure or so on. But the biggest challenge with this kind of adoption is we get a lock-in into a vendor. We can't move across vendors. So you can't have a function, an Azure function work seamlessly on Lambda and so on. So if you start using serverless, you get logged into one specific vendor or a provider. Whereas containers, it's different. So if you start to build Docker images on Azure, you could take the same Docker definition and deploy it on AWS. You also could have clusters spanning across two cloud providers and have a multi-cloud environment wherein pods are being spun up and spun down automatically using orchestration. They're very good for rapid automation and processing small amounts of data at a huge scale, and they also have kind of predictable cost. So this is the difference between containers and serverless. Both of them work. Both of them are useful for their own use cases. But if you're looking at something that's more scalable and you want to kind of predict your costs and you have something that's a long-lasting task, it's better to choose a container rather than go in for a serverless, which is more of an event-driven or a single task kind of an activity application kind of a thing. Next slide, please. For the cost comparison, VMs and containers are very similarly priced because we still get access to the underlying fabric. We get access to the virtual machines. We get access to the environment that's actually hosting the container definitions. So we are still charged for that. And if you're using a management tier such as Kubernetes on either AWS or Azure, AWS it's called EKS, Azure it's called AKS. Both of them are the same flavor of Kubernetes. Then there's an additional overhead charge from the platform tier as a management layer. And for serverless, it's completely event driven. So you get charged per execution, per process time. So if a process takes a lot of time to complete, then you get charged more. So serverless, again, it's completely different from a VM-based deployment, and it's very, very ideal and good only for a single operation, like go get this file or go post this message, and that's it. Nothing else. No more additional tasks for it.
A common usage pattern here for serverless that is used as a demo in a lot of books is you upload a file and it gets resized, like a photo, and it gets resized to a different size, like when you upload a profile picture to Twitter or something, because that is a single use case. It's very rapid, and when it's done, it spits out the file and it finishes.
And just to add, what comes to mind for me is that, in UDP, if we have weekly loads that are coming in and we have to process that data and put it in the data lakes, then that would be serverless, because the rest of the time it doesn't need to run, right? It's only when data is coming in on a weekly basis, for example.
It would depend on how long it takes to run, but absolutely. If it's a small data set, for sure. The UDP group right now, their data sets are so large that those jobs would take longer than serverless generally supports, which is really short. It's like 5 to 8 minutes is the limit across AWS and Azure for serverless jobs.
True.
So they do something called batch, which sort of like spins out a container or spins out some virtual machines, and they do stuff. But yeah, totally. As we see serverless progress, I imagine longer jobs will be better supported, and we can move it to that.
And just to add to that, actually, ECC team is the best example for using serverless. They use serverless functions across all of their applications right now hosted on Azure. Basically, the function gets triggered whenever someone uploads a file, and it pushes the file to a different location, or uploads it to a database, or it does something else. Like it's just a single task which runs for maybe like 2 seconds or 3 seconds or something like that, and moves on. That's the advantage of serverless. Yeah. And for those scenarios, using containers is not really efficient because it's going to be very expensive, and it's going to be a huge management overhead for building building the image, hosting it, maintaining it in the VM, and updating the management layer and all of those things, which is unnecessary for this kind of tasks. So again, there are no winners between both of them. Both of them work very well. It's just that your scenario has to be defined for it. So the next thing we can talk about is the provisioning as well as refreshing the entire environment. So if you had a traditional VM-based environment, and if you have to refresh it, it's going to be a huge cycle of effort, because it's going to take the whole VM has to be updated, has to be redeployed. It's a massive footprint. You have services, underlying framework to be kind of managed and updated, and all of those things. It's not going to be a simple thing. And we all know managing VMs day in and day out, even if it's a simple domain controller, or even an advanced or a complicated network, a SQL cluster, we know that when we touch a VM, it's definitely going to take a lot of time to finish all the tasks on it, update it, ensure everything comes back online. It's part of the domain, authentication works, all services are up and running, and we don't want to do it again and again. It's not really kind of effective for us. So, but then when you switch to container-based deployments, it's much more easier, because the underlying kernel is not something that we manage. We only care about the pod or the container that's actually running. As long as the dependencies and the application is updated, that's what we need to do. And using orchestration layers such as Kubernetes, you also could do a blue-green rolling update, wherein you actually push an update to the container pod or the container image. Kubernetes takes care of updating all the instances of that container automatically without having the application to go down. So that way, we really don't have to have a downtime, and our customers aren't impacted.
Sai, can I ask about that and make sure I understand what you're saying there?
Yes.
So, are you saying that, like with Kubernetes, if you have let's say you have a fleet of hosts, like underlying servers that need to have the kernel updated, that Kubernetes handles like shuffling the containers amongst the hosts while the hosts are being updated? Is that what you're saying, or am I misunderstanding that?
So it doesn't do the host, it does do the pods. I don't think the Kubernetes actually maintains the host, it only manages the pods. That's the container's image itself, not the host itself. So if suppose the host needs to be updated, that VM has to be taken offline and updated automatically. And when we do that, Kubernetes, kind of notices that the host is going offline and those pods are dead. It stops routing traffic to those pods. It only manages the other two the other two servers or three servers in the environment.
Okay, so it doesn't have like a vMotion type capability of moving the containers of the pods around. It just knows that when they're dead to not stop routing traffic to them. Is that right?
It does spin up. So yes, but then it also, suppose for example, in the definition of the Docker and the Kubernetes definition, we say that for a web front-end pod, I need to have 10 instances running all the time. Mm-hmm. And if it is noticing that one of the servers that's actually having four of those pods are going offline, it'll spin up the remaining 4 in the rest of the 2 servers that it actually has access to. It'll ensure that we still have 10 all the time running. It'll not let the scale go down to like 6 or 4 or something like that.
Good. Yeah, that makes sense. And so, what would the best practice be? So it sounds like if you need to update the kernel, then you can do that in Kubernetes or whatever that will kind of take care of your capacity needs, right? As you're doing like a rolling update. If you wanted to update something that was actually on the pod itself, say like a new version of the website or something like that, or even like if you're running like SmokePing in a container, for example, like the version of SmokePing, you wanted to update that. Is the convention of the best practice just to re-provision the container with the new version there, or is it updating the live container, or either? It doesn't matter. Like, how is it typically done?
So from my understanding, we published a new image into the Docker registry, the container registry, and there is a recycle time wherein. So I think it depends on how it's defined. So you could have a recycle time wherein Kubernetes checks the container registry for any latest images and deploys that image across all the environments, all the pods.
Okay. So you wouldn't update the existing pods. You would update the image registry, and then that would like kind of auto handle getting the new version out there.
Yes, but it also depends on the configuration. Sometimes you could do a manual thing wherein we manually go and update the new YAML file and the definition to each pod. The best approach is to do it automatic and let Kubernetes manage the deployment updates and everything on the pod itself.
And in this case, when we're talking about the container registry, this is like a literal container image, not like a config file, right?
Yeah. Yes. And
like
an image
pre-built or a pre-built image. Yeah.
True. Yes. But that is what. So the image is exactly what we define in the config file, because the config file, as Tyler was showing, has all of these packages to be installed and everything. The images that.
Yeah. But so I'm understanding it correctly. It's like the equivalent of like if you're doing a VM with Packer, right? Like the image in the registry is like a Packer VM. It's a pre-baked image that's good to go. You can just launch. You don't need to. Yeah.
Yes. And serverless, as we just spoke, it's the simplest way of doing it. We don't have any underlying framework or management of servers, anything like that, and we just do the application updates.
Yep. We touched on Kubernetes earlier. Are you going to have? Do you have a slide coming up on Kubernetes specific, or should we talk about? Okay, I'll wait.
So 2 more slides, and I have Kubernetes. We didn't kind of deep dive into it. We just spoke about orchestration as what exactly it means, and Kubernetes is the most famous one. So I just cover that in a few minutes, like 2 more slides.
How is the dog Mario related? Is it just the?
Okay, so
that's kind
initially this was going to be the pet versus cattle, and I was going to say you don't want to get rid of your puppy, right? But it's on the wrong slide now. So,
and Sai, Kubernetes does like a health check of the pods, right? When you set the replacement, so it keeps checking the health, and if a pod seems to be dying or going down, then it'll, based on that health check, it'll replace that pod.
True. So as we saw in a few slides before, right, container has multiple weaknesses. Like if you run Docker by itself on your machine or on a server, it's not going to be very efficient, because they become like cattle, and it goes everywhere. You can't manage them. Something might be not having healthy status or something like that. It kind of becomes a difficulty to manage it eventually. that's where orchestration comes into picture, and that's where Kubernetes comes into picture. So Kubernetes does monitoring of the pod. It actually does keep a track of the health of the pod. It does know what's happening within the pod, and if it is having some error, or if it's gone into a hung state, or if there's even if there is a event that's being generated on the pod itself, it can surface it up to the administrator to see what's going on so that they can further troubleshoot that pod. And worst case scenario, suppose the pod just goes offline and it doesn't come back up, it'll ignore the pod and it'll try to spin up a new pod. And while that's happening, it will have traffic routed to the other pods available. And in my terminology, pod means container.
Yeah. Thanks.
Sure.
Hey, Sai, totally left field question. Did I read something recently about Kubernetes deprecating support for Docker?
So Docker actually so Docker is to run on a service called Container, the RD. There's been a split or something like that, and a lot of Kubernetes and like basically Azure and I think AWS also has switched on from using Docker process to the container process, and that's where they run all of their images right now. They don't do Docker technically. So
it's still using the Docker container format, I think, but yeah, they're changing runtimes.
Gotcha. Yeah, the underlying process is changing. Yeah, the definition, everything's the same though, because Docker is to run on the same runtime earlier. So we spoke about this like a few minutes ago. Updates and monitoring VMs are very difficult to manage. We know how challenging it is right now. We live through this every day, so we know how challenging it is to manage it, update it. And every time we kind of touch those machines, they tend to have a downtime and applications go offline most of the times. But containers, again, we don't have the challenge because the kernel is not what we're touching. We're just touching the pod itself. And suppose we see a pod going to a failed state or something else, we can revert to the earlier image. And if you're using orchestration services such as Kubernetes, it will do a rolling update. So there won't be an impact directly to the application or to the end user itself. And serverless, same thing. We don't manage the environment. We don't manage the OS. We don't manage anything except for the one process that's been given to us. And we only need to ensure that our application doesn't have any vulnerabilities or security issues. Other than that, we don't really care what happens at the back end because it's managed by the provider.
Though, Sai, on that one for the containers, in case the underlying host system is being patched we do still need to test our container to make sure that it continues to run and is not hampered by the updated patched system. Right?
Yes. So those things you will need to bake in when you build the container image. So as part of the build process, when you develop the container and when you're doing testing and everything, we do have other environments where we can test this out successfully. The biggest advantage we have in this case is that since we're doing rolling updates, the application doesn't really go offline, unlike a VM. Like there might be performance impact and other stuff. But in this case, you'll always have a pod running on the network, which is taking up request and processing server issues and so on.
Thanks.
Yeah, and the big topic is about security monitoring. The advantage of using a VM is we have a lot of tools to manage security on them. We have, Defender, CrowdStrike, and so many things installed, antivirus, and you have firewalls and all of those things configured. So VMs to a certain extent of time used to provide a lot of security, but then that's not anymore the case. For containers, in our environments right now, we do proactive scanning during the build phase itself. We have integrated Prisma. We have integrated even a tool called Aquasec earlier, wherein it actually tags along the DevOps job itself. And if there's a vulnerability in the image, if you're using an older version of Java or something else which is having open vulnerabilities or 0 days, these tools will actually block the image from being built, and it will actually throw an alert saying that, hey, this is using so-and-so version, please update it. Other than that, if in case we miss that step and we publish an image to the image registry, we do have, again, tools there which actually scans everything, and it actually lets us know that if an image has become vulnerable over the last few days because of a new vulnerability discovered in the version of the environment that they've been using. And the last and the final thing that we also do is we also have pods that actually run within each container cluster. These are Prisma and AquaSec pods, which do runtime scanning. And if any container is kind of behaving wonky, or it's trying to access network which is not supposed to be doing, or even if someone does an SSH into a container pod and tries to elevate themselves to a different version or a different user, these runtime pods actually notify us saying that, hey, there's something going wrong in the container itself. So that way we have multiple layers of security tied to the containers, and it does give us more security than compared to a VM-based deployment. And Mike, I think you're asking questions on this, so hopefully this answered your question.
Yeah, so if I can make sure I've got it. So we're scanning on build. You could do runtime scanning. Is that what you're saying?
No, we are doing runtime scanning as well. So there are services that do runtime scanning as well.
But you wouldn't deploy like a full-on, like you wouldn't deploy CrowdStrike. You wouldn't deploy like a full VM base. Is there, like, I guess there's something specific for containers?
Yes. So for containers, we have container images that come with runtime capabilities. Like Prisma provides them and AquaSec provides them. They run alongside with the container pods and monitor them for any suspicious activities.
So it's not running on the container itself. It's running adjacent.
Yes.
Is there like an agent on the container, or how does it?
The pod itself is the agent. The container pod that we are deploying, the Prisma container that we're deploying, that's actually the agent that has access to the kernel of the VM that's actually hosting it.
Yeah. That makes sense. Okay. And then like performance monitoring of the container. Do you have a slide on that, or can I ask about that?
No, please feel free to ask it, but it's coming up in the orchestration. It's the next slide.
Oh, I don't want to steal your thunder. I'll wait.
Sure. Sure. So, and this is it. So orchestration is, I think, the best solution we have for all the weaknesses that containers by default have, because we don't control Docker images, we don't control how they run, how they spin up. And if every time a pod is failing, or a Docker container is actually failing, it becomes difficult for us to understand, manage it, and then redeploy automatically. That's where orchestration comes into picture. And so they provide us options to manage them, do operations on them, like updates and everything, and also monitor them. We can monitor them for events, like general events on every pod. We also can monitor performance on them, and we can see the health of them. If there is high CPU on a certain, suppose one specific container is taking up high CPU and processing something for a long time, they actually can get those alerts, surfaced up to the Kubernetes environment. And from Kubernetes, we have dashboards which we can actually create, and it shows us a live environment status of what's happening. On Azure and EKS, I don't know much about EKS, but on the Azure side, what they have done is they've actually surfaced up these reports into the Azure portal itself, and tied it up with app insights and container insights, which gives us a real-time status of each pod, what it's doing, and what's its status, like its health, its version, what packages it's running, and what its network status is. So that's all given to us from the orchestration layer and surfaced up to the provider's platform, like Azure, and given to us as part of logs and real-time statistics. They also help us provision, build, and load balance all containers. So like we were talking about container networking, which is a little difficult to process. So the orchestration services actually gives ability to manage them more efficiently. Pods typically try to run in an abstraction from the original network. So they have a different address space, internal and specific to the cluster itself. And they get load balanced, and the load balanced IP is what we get to see as consumers of the container environment. All of these is managed at the orchestration layer. The famous tools for orchestration, we have multiple of them, as we're seeing over here. So Kubernetes is the original one, which was Google born. It's no longer actually owned purely by Google. I think most of the founders of Kubernetes actually joined various other cloud providers. One of them has joined Azure, and they have kind of enhanced their own platforms, Kubernetes capabilities, along with contributing to the open source community as well. I think right now Kubernetes is in 1.19 or 1.9 version of the environment, and they have a lot of good features baked into it. Another one is OpenShift. It's native to Red Hat. I think it's very prominent for people who are using it on-prem or building up their own clusters and so on. I've not used OpenShift in the past.
So Kubernetes and AKS are both Docker under the hood, or no?
They are Docker definitions, but running, like how Mark was saying, they actually run on the containered process. The runtime is contained, but yeah, they're all Docker to simplify.
Okay.
And the best comparison I've seen for Kubernetes is it's a Lamborghini. It's amazing. It has every feature in the world, but it's also very complicated to maintain. And that's why there is an AKS service from Azure and an EKS service from AWS. They will do the hard part for you and help you configure Kubernetes.
Yeah, that makes sense.
And maybe in the next 201 we have, I can show you a demo of Kubernetes. I can show you the dashboards and maybe even do a live pod deployment and so on.
Yeah, and with AKS, EKS, like basically they're handling the kind of overhead of the or the orchestration layer. They're handling the overhead of the hosts, under the hood, right? I mean, so they're really abstracting a lot. It sounds like. Is that fair to say?
Correct. So on the Azure side, and I think that's the same thing in AWS as well. There's something called a managed Kubernetes service, wherein we just get the orchestration layer to us and enables us to deploy pods, that's containers within that orchestration. And the underlying framework of kernel, the VMs, the OS updates, all of that stuff is managed by the platform itself. So we, even though we might have access to those VMs, it's prefer that we don't touch them, and it's managed by the cloud provider itself.
Okay. And so, I mean, conceivably, like if you wanted to, you could, have a bunch of Linux servers and that running Docker, running Kubernetes, your own, if you were so inclined.
Yes.
But that'd be a lot of overhead. Okay. Makes sense.
Yes. The overhead will be that you have to do clustering. You have to have the cluster service running on all of them, and then, pair them up, load balance them, do all the networking stuff, and then install the tools. Yeah, which is complicated, and it's doable if you're running on-prem environments, vast networks. Maybe I'm sure Netflix and those guys are doing something like that, but for us, it's not relevant.
And to address that complexity point, that's something that Sai and I will try and tackle. Just like everything else that we expose y'all to, there's a lot of complexity behind the scenes, and we do our best to lower the bar so it's easier and you can just focus on the cool thing it can do instead of spending a year learning how it works.
Yeah, that's really interesting. Yeah, you guys know I hate servers, so I would never install this on my own servers.
That's something that Mike mentioned. We're declaring war on servers over the next couple of years, so containers and serverless are going to be key there. Okay, let me take over for 1 minute, and I have a little demo for y'all. We went back and forth on what to do for a demo for should we build a container? Should we push it to registry? Should we run it? We decided on something simpler. So you can see on screen, these are one-liner commands once you have Docker installed, which you just download and install, and they will spin up a container for these specific runtimes. So Ubuntu of 16.04, CentOS 7, CentOS 8, and you can just play around with them, and they take 2 seconds to spin up. And I've used this to troubleshoot Bash in different versions of Bash or different runtimes of operating systems. So super cool little trick that it can do. So let me share my screen for a second, and I will show that to you. So you can see up here, I've got my little Docker guy running, which is the whale with containers on its back, and it's doing a little beach ball because it's very slow. But here's my one-liner, and I can just from anywhere on my computer run it, and you can see it's doing stuff, and we're done. So if you were to go and say I had VirtualBox or something, and I wanted to spin up Ubuntu 16.04, I'd have to go download the ISO and then provision a machine and then boot it up and log in. It would take longer than this, than 2 whole seconds. And you can see I'm in here, I can run changes, but remember this is a Docker container. So as soon as I exit, it's gone. It's terminated, the stuff that was in memory is finished. Here's Cent8, I don't think I've run this before. We'll see, oh, I totally have. So I can see oh, I'm in Cent8, who am I? I'm the root user there. For 2004, which I'm pretty confident I've never run before, it's going to say, I don't have that. I need to go find it. So it checks into Docker Hub and it finds Ubuntu with the tag of 2004 and it booted it. Like in that time that I was talking, it downloaded the thing, booted it, and I'm dropped into a command line. So these are all in the wiki for you to play with. Like we've mentioned, there's tons of stuff in Docker Hub for you to go play with and experience Docker. And this is a really lightweight way to do it, which is Docker run a container with this tag in interactive mode and drop me into the shell. We have a couple more minutes. We could certainly stay longer if anyone would like to. There we go, all the way to the end. So that's Sai and myself. You can find us on Medium, GitHub, and Twitter. We're also the cloud platform team here at Veradigm, so easy to find us in team-cloud-platform in the Slack room. This recording and all of the wiki information, the one-liners you can use to experience Docker yourself will all be posted in the Veradigm-DevOps room as soon as that recording is ready. If you have any questions, bring it on. If not, that's all we have for you all today. Thank you for your time.